This is Evolution MV with Marcus as your host. Further details at inquiry@thinkware.com. That is a Q in the middle. Today we're going to have the long-awaited beginning programming session for PIC. And this is not what we will be doing. You may not even be able to see that on your screens, but that is a classic green screen view. A lot bigger than my original one, but we don't build bottles, ships in bottles anymore, certainly not little green bottles, which is what those old cathode ray tubes were. And that's what I was introduced to back in 1994 when I started working at this company that produced this software. And that monitor was about a 15-inch monitor, and you see the extra black border around there. Didn't leave you with a lot of room. You had 80 by 24 screen and just one color. This was one of the better ones, being amber. And this right here is literally about the size of what I had to work with originally, initially. And I am not going to inflict that upon you. Just wanted to show you what that looks like. We have much better tools. Although, amazingly, a lot of PIC programmers are still accustomed to using a stone axe. They're just comfortable with it. It's what they know. They're very good at it. The muscle memory's there. But, as I said, little 80 by 24 green screen bottles, no. It's time to move on from there. But I will show you those older tools. Now, as I said before, in PIC, it's all about the files and the items. Now, the files are roughly analogous to a folder, a subdirectory on Unix or Windows. And you would create a folder probably a lot less frequently than you would create the files, what you call files on Unix and Windows, that go into it. And the same is true on PIC. So before you do anything, you have to have a file to do it in. And most often you will already have a file because you've done this before, but we've never done this before, and I'm showing you how to do it. So we're going to create a file where we're going to store our basic programs. Now, out of convention and history, the program file is named BP or something with BP in it. I don't actually follow that convention, but it's one that I should show you guys. Now, normally in PIC, when you create a file, you just specify the name of the file. And both the dictionary portion and the data portion will be created simultaneously. But it doesn't have to be. You can specify dict BP, after which you would then create the data portion for the BP. And the reason you do that is, especially if you're creating a multi-partition file, a file that has multiple data partitions under it, or portions, then you want to be able to name them whatever you want to name them, and if you create both at the same time, you get the same name for both dictionary and data. So, we're going to create BP, and in any other PIC except OpenQM, which is what we're using here, you would have to specify the modulo for both the dictionary, because that's going to be created, and the data. They have to be prime numbers, and they have to be large enough for all the data you plan on having in there. We'll go into those later on, but on OpenQM we don't have to specify those. So we'll just create file BP. Now we're also going to want to have data, and this program we're about to write will be about personal data, so we're going to create a file called persons. Now, this already gets into some of the more advanced stuff. I feel it's very good practice to always name the database you're going to be using, creating, something that reflects the data that's actually in there so that anybody who looks at it knows immediately what it is. Now, sometimes with some of the data you create, especially some of the more technical files that shuttle data or deal with connections between other files, they can be a bit difficult to name, but use your imagination. Naming things, by the way, is probably the most difficult thing in programming, and one of the big motivations behind things like object orientation. So I would say invest some time in thinking up a good naming convention, or look around at other people's naming conventions, see what you find that's good. I have my own. I'll be showing it to you. The other thing I feel is that databases should always be plural. because it is a collection of things. I've actually seen people call theirs things so that they could put almost any kind of data in there. So we're going to create file persons. Again, in OpenQM we don't have to specify the modulo separation or anything like that. And now that's created. If we list BP, there's nothing in it. If we list persons, there's nothing in it. Nor is there anything in list dict persons. We do have the ID. There's only the one record, and that ID will be used later to show us the IDs of any records we put in there. So we're going to go right to the program. Now here's ed. And I think I told you before that ed is roughly equivalent to the old DOS edlin command. And if you ever had to struggle through that, you'll understand what I deal with when I have to deal with this. I really hate ed. I do use it just for automation though. So edbp, you always have to specify the file name, and then the item name, even if it doesn't exist, you want to create it. So test. And there we have it. We have a new item. To start adding lines to the new item that you just created, you have to use I for insert. And the first line you're going to want in any program is program and the name of the program. Now, this is immediately going to start a firestorm of controversy with a lot of PIC people who never do this. It's old habit. I consider it a bad habit. It's one that I thoroughly understand though. When I first started dealing with PIC, I didn't do it either. But as I learned the value of structured programming under PIC, it occurred to me that you've got to carry that out all the way from top to bottom. And so, any subroutine in PIC must start with the subroutine keyword, any function must start with the function keyword, and they both end with return. So program should start with the program keyword. It's consistent, it's understandable, and it does work. People have never heard of it. They don't know that you can use it, but you can use it. And the reason you use it is this right here. Whenever you start a structure, you have the opening of the structure and you have the closing of the structure. The closing of the program structure is stop. And it seems sort of silly to have a program that has a stop that doesn't have the opening of that structure. Hit enter a couple of times and it puts you back to the command mode of the editor. So we go to T for top and P to page down. There's our program, such as it is. Now we're going to go back to line 1 because we're going to insert after line 1. Insert always comes after the line you're on. We're going to indent 3. Remember, we're doing structured programming, and structured programming is really all about two things. The beginning and ending of the structure and indentation of everything in between. Has a lot to do with visual acuity, and visual acuity is everything when you're trying to analyze code. So this program is going to take a first name and a last name, and it's going to add it to the database. Super simple program. But we can't just accept data, we have to tell the user what it is we're up to. So we're going to put something on the screen that tells the user what we're doing. And the command to put something on the screen, there are a few of them. Print, CRT, and display. I prefer CRT. It comes from cathode ray tube, back when cathode ray tubes were a new hot thing. The display and the CRT command do the same thing, they just show something to the screen. The difference between this and print is, in the PIC world, and a lot of others, the old host terminal computing environments, you can switch your terminal to print to the auxiliary connected printer. And what that means is the terminal could have a printer connected directly to it as opposed to a terminal connected to the host, which to most of you would be the server. So, and why would you want to do that? Well, because you want to have a printer at your desk to print things out, back in a day when people still did use paper, but also because you want to do debugging. So you can capture data going back and forth over the line by sending it to the printer instead, so you can analyze it and see what's really going to the screen or coming back from the screen. But that requires the use of the print keyword. The print keyword will allow you to switch the output over to the printer. CRT prevents it from doing that. We're going to use it here because we don't ever want this to go to the printer. Even if we're in debugging mode, it makes no sense for this to go to the printer. And I use the single quotes. The single quotes will define a string, a literal string. And so we want to tell the user that we want them to enter your first name, and a semicolon, just for visual acuity, a space, and the closing semicolon. Now we're also going to add a semicolon, that's a colon, and this is a colon too. Now, why a colon? Traditionally, PIC has always automatically assumed that anything you print to the screen, at the end of the string, it should add a carriage return and line feed to start over again on the next line. It's a good assumption, and it can actually make for some pretty clean code, but very often you don't want it to do that, because we want the input to happen right after the end of this string when it displays on screen. So we add the colon, and that tells the program, whether you're using compiled code or a runtime module, it says do not terminate this string with a carriage return line feed. So it'll leave the cursor flashing right there. Then we hit enter, more indentation, and we're going to say input fname, CRT, that wasn't good, enter your last name, space, quote, colon, and then input name. And then we will show them just sort of as an error check for now. You entered, boy, I just cannot type today. Fname, we'll fix that later. Name, okay, so now let's go make some changes to show you how editing works here, or correction. Now, there are two primary flavors of PIC. In one, it's always visible in the editor, by the way, and at the command line. In one, you use change. In the other, you use R. So we're going to change that colon at the end, just because I'm kind of weird about this. We want that extra space in there, and we didn't put it there. So I'm going to say C to change again. I don't want the space after that colon. I want the space after the second one. And that has the quote in front of it. And the pipe symbols you see me using, you could use backslash or forward slash. It just wants to see a character to delineate the different sections of the command. There, now we have the extra space there. See how they line up now? And I'm a little OCD perhaps about the lining up. But notice that I have the backtick here. There's a reason for that, but it should be here too, and I didn't put it there. Plus I mistyped entered. So we're going to go there and fix that and say change, what does that say there? ENTREDE space. We're going to spell it correctly. Entered backtick. Close pipe. Now it looks right. And notice that I entered FI to file in lowercase. Almost always it's recognized. You don't have to worry about case sensitivity here. PIC tends to be uppercase only. That comes because it was born back in the day when computers were uppercase only. In fact, the lowercase characters hadn't yet been added to the extended ASCII character step. So there was a separate command for shift that went out over the teletype. And ASCII comes from the teletype days. And the teletype character set only needed to be 7 bits. The 8th bit was used for error checking, which gave you 127 characters, 128 with 0. And so one of those would be shift, and it would literally tell the teletypewriter at the other end to shift to uppercase. So you typed everything in uppercase, the uppercase on your keys. If you look at your keyboard, everything's uppercase, right? So, but it knew at the other end, it knew to type by default in lowercase, and when you wanted uppercase, it would shift. Later on, IBM changed ASCII to the extended ASCII, and we got 255 characters, and we got 26 of those being the lowercase characters. So if you look at the ASCII table, you'll see the uppercase characters come first, then come the lowercase characters, because that's how that evolved. A little bit of history for you, huh? Now we want to compile this. Now in PIC, it's always basic. There is a compile keyword, and there are some differences we'll get into later, but traditionally it's basic. The name of the file and the name of the item. And there we go. It compiled. Now in PIC, you also have to catalog if you want to be able to run the program from the command line without any complications. Otherwise, you have to specify run BP test. But if you want to just be able to enter test and run the program, then you have to catalog it. Log BP test. I think on this system we have to do local. So if you look in the master dictionary, that's copy to terminal, master dictionary test, I believe we should see it there, and there it is. That is the verb entry for the program. Remember I told you PIC has the paradigm of the English language. Nouns are data, they're the things that are worked upon, and verbs are your programs, your procs, your paragraph, such. And so you have verbs and nouns, and they're in the dictionary. That's where everything's defined, and this is the definition of that verb. So if I type test now, it will run it. And it asks for my first name. We'll say Marcus, last name, Rhodes. And we have an unassigned variable, fnabe. Oh, that's an error I failed to see. So we're going to say ed BP test. And we're going to go to line 6. See, people used to think that was so comfortable. You got such error checking, it could tell you exactly where to go to find your error. And I believe in JBase it even tells you the column on the line to go to. And there it is, the evil B that should be an M. So we're going to say change that B, and there's no other B there to worry about, to an M. There it is. File it, compile it, or basic it, basic BP test, and it's still cataloged. Watch this, ctmd test. We never have to catalog it a second time unless you're using JBase. JBase, for some reason, they decided it would be cute, clever, whatever, to do the final compile, or the linking, or whatever it is they do, when you catalog. So every time you basic a program, you have to catalog the program too. And rather than using the MD, they use the operating system's, file system's own path and environment variables to identify whether you've got a global program, a local program, or a private program. So now we can just run the program and enter my name again. If only I could do it right. It's going to get that wrong. Huh, no, it did work. So up arrow to run it again. Now let's see if I can type this time just because I'm challenged. There we go. I entered Marcus Rhodes. But that's not enough. But there's just no way, there is no way that I am going to continue using ed to develop this piece of program. Because I'm not insane and I'm not a masochist. So I'm going to use a more comfortable tool. And I've already written this program anyway. So I'm going to show you I use the Nano editor when I'm using GNOME terminal. And I wrote a program to automate all of this. emvdev, that's my personal program file for development code. And there's the test program. Now hold on, you're going to like this. See that? Now I've customized this a bit, you could too. GNU Nano, I think from 2.1 onwards, or maybe it's 1.7, you can customize it. You can customize the keys. You can change all of those, that's your menu. There's your help screen to show you. And you can customize the syntax highlighting. So I have written my own syntax highlighting for Nano, and I will share that with you. I'll put it on my website and give you a link to it. So here's the full program. You remember we wrote enter your first name, input F name, enter your last name, input last name, and you entered. But then we want to write it somewhere. That's the whole point of gathering data in the first place, is to store it somewhere. So what are we doing and why? Well, remember I told you when you create the file, you always create the dictionary portion. It's true you can create a dictionary portion by itself. You can even create a data portion by itself without a dictionary portion for some insane reason. I'm sure there's something clever that I don't know about, and someone will tell me about it. But you always at least create a dictionary portion. And remember that the very foundation of the system starts with a dictionary portion only that has no data portion associated. That's the system file. The system file points to the account master dictionaries, which are themselves, again, just dictionary portions. The master dictionaries will then point to the file dictionary portions, and then the file dictionary portions can point to whatever data portions they may have. We do have a few files on the system, though, that are just dictionary portions without any associated data portions. For example, the save list file. There's really no reason to have a data portion because it's random data. It's not going to require dictionaries. Dictionaries are the home of the those items, those special database items that are used to describe the data as you list it, but that's completely out of context for the save list file. What is the save list file? We'll get into that in another session. So anyway, we opened the dictionary and we named our file persons, so it's dict persons, and like I said, that will bear fruit later, and right here is the fruit, DCT persons. I always use underscore. You'll see a lot of people use $sign. I think the %sign works, or a dot, period. I prefer the underscore. I have my reasons. We'll get into that some other time. But you could read this, right? Open dict persons to dict persons. That almost makes sense to a human being. And then we are going to read u person key from dict persons key list, else person key equals 0. What are we doing here? Well, first of all, the read u is read with an update lock. What is an update lock? An update lock puts a freeze on that item in that database, and it prevents anybody else from doing anything else with that record while you're using it. When you're working on a multi-user system, which is almost always going to be the case, update locks are essential. If you don't use them, you will break things. You will hate life. Always use update locks if you plan on writing the data back. We plan on writing data. And the data we're going to be writing back is the key, the name of the item that we're about to enter into the database. We've got my first name and my last name, but we're not going to save the record under my first name and my last name. There are dozens of people with the same first name and last name. We would overwrite their records. We want something unique, and there's nothing more unique than an incrementing sequential number. Always a good idea to use that, but you have to store somewhere what the last record ID used was. And typically, generally speaking, you don't ever want to delete data out of a database. That's sort of anathema to a database. You never remove anything, so you don't have to worry too much about recycling keys, but we'll get into that idea later because there are times where you do have to do that. So we can just count on this being a sequential incrementing key. We'll start off with 0. We will actually never have a 0th record. So we attempt to lock that record. Shouldn't be anybody else on the system. If there is and they have it locked before we get to it, we simply wind up waiting for them to release the key. And we'll be releasing the key just a few lines further down. This is the name of the item in the dictionary. Remember, we opened this to dict persons. So we're going to read out of the dict persons, the dictionary portion of the persons file, an item by the name of key underscore list. And that will be our list of keys. And I've named it list for a reason that I've already described. We'll get back to later. If it's not there, the else clause is executed, and we simply set person key to 0. which it's not going to be there our first time through. But if it's a 0 or whatever it was we read, that means that key was already used. We can't use it again, but it's a number, so it's easy to increment. We simply use a very common and well understood programming shorthand to increment by 1, and that is person key plus equals 1. So since we were the first person to grab it, we set it to 0, it then gets set to 1. What if we weren't the first person? What if there is another record out there? Let's say there are already 200 records out there. We would have read person key. It would have had something in it that would be a 200. The else would not execute. Then it would come down. It would increment it to 201. So now we write the person key back. And when you write the record back, if you just use a write and not a write you write the record back, it clears the lock and somebody else can use it. If you want to keep the lock, you use write you. And by the way, if you just want to give up the lock without writing anything, you changed your mind or something, it's release. DCT persons key list. And that would just release it without doing anything else. So we write our key back. The key will now have a 1 instead of not existing at all. Then we open the data portion, and you don't have to specify data. By default, if you open a file, you are opening the data portion. If you want to open just the dict portion, you have to specify dict. Just sort of an interesting convention. So we open the data portion of persons to the persons. Then we read you, remember with a lock, we're creating a new record. Read you the person from the person's person key. Else, and the first time we create this record, and that's almost always going to be the case because that's what we're doing with this program, is adding new records to the database. Since the record isn't there, the person becomes null, initializing the variable. Why? So that we can do the next 2 lines of code. This is what's called a dynamic array. We'll go into this in more detail later. For now, all you need to know is this is very much like a dimensioned array that you don't have to dimension. And instead of being different variable locations throughout RAM, this is one string. The brilliance of PIC rests, I feel, on 3 or 4 things. One is the typeless variables and the basic programming language. Another one is the saveless file, the English language, the dictionary versus data portion structure of the file system, the very flat file system, and dynamic arrays. They are brilliant. They work wonderfully well. So in field 1 of the person item, we store the F name. In field 2 of the person item, we store the last name. And then we write, without a U, the person on the person's person key. I believe some PICs allow you to say to the persons. What I learned with ON, and it kind of makes sense to me in a database context. And then we copy to the terminal, done, so the user knows we're done. Now, if we had not been able to open persons, the end else, the else clause would execute, telling the user. And we put it here because I want to impress upon you right up front to do error checking on almost everything you do. I've seen strange things happen to systems. You think records have been written, they didn't get written, you think files got open. You've got to have the else clauses there in every case, just in case anything goes wrong, and it's got to fail loudly. It's an old maxim. You can't just write it to a log somewhere. You've got to sound alarm bells. You've got to let somebody know right then at that moment it went wrong. The log files are for the system administrator to pore over later. Maybe they can use them to figure out why it went wrong. But at that moment, you don't want the user doing anything else. If anything went wrong, you want to stop the show. And so we're going to fail loudly here. And very often what you would put after something like this is something like a log off command to force the user off the system until the problem can be fixed, because a problem here is major and they shouldn't be doing anything else. But here we have our program, and I'm going to save it as it is, and I'm going to copy it to our BP file. copy env dev test with overwrite, and that's what that O means. Remember I told you before that paren is the beginning of the options. Some PICs allow you to close that with a closing paren. I think others, the newer ones like JBase and OpenQN, they didn't grow up in that tradition, so they don't know about that, so that's technically illegal. And we're going to copy to with redirection because we're going to a different file. If we were going to the same file, you could just give it a different name like Mars, and it would copy it within the same file from test to Mars. But we're going to a different file, and I can tell already that's not going to like that. Copy the open paren again becomes redirection, BP, and that's all we have to put is the file name because we don't want to change the name of the item. If we wanted to change the name of the item, we would say test. We didn't have to do that. And it copied it. Now just to be sure, CT, BP, test. There's our program. Now we're going to basic it, BP test. And remember, we don't have to catalog it. It's still there, CTMD test. See? Now we're going to run test. Enter your first name, Simwa. Je suis français. Rhodes. And it tells me I entered Marcus Rhodes, and I'm done. Very good. So now let's look in the database. Let's list persons. Let's see if I can see myself there. I see a 1. Where am I at? Well, as I told you before, let's look in the dictionary to see what's available. CT dict asterisk means for everything. It's a wild card. CT dict persons. How about I do it right this time? We have 2 items. One of them is the ID. And we saw that up here when I list persons. That's what the ID does. Persons 10 left aligned, and it shows me the number. Well, I don't want to see the number. I want to see what's in the record. There are a couple of ways to do that. One is this. By default, this flavor of PIC uses F field number for the different fields if you don't have any dictionary items otherwise to describe them. So you would say list persons F1. Remember we put it in persons 1 and persons 2, F2. Ah, there we go. That's the data we entered. Now, just so you know, on other databases, remember I told you there are 2 primary flavors of PIC. The other one, by default, would require persons for non-defined field names. It's star A1, star A2. Just in case that's the kind of PIC you're dealing with, and that would be D3, JBase, I believe there's another. So, but we don't have any dictionary items really to show that. So we're going to create one. We're going to say eddict persons fname. And this is going to be an attribute defining item. Any other dictionary items pointing to this field, by convention, should be called synonyms and would have an S up there. Now 2 is where the field number goes, that's 1. And then on 3, the label. And this is going to be, that's going to give an error. That's going to give an error. Come on. 3, replace it. First name. Okay, now we're going to insert some blank lines. 4 we don't want, 5 we don't want, 6 we don't want, 7 we don't want, 8 we don't want, but 9 we want. And that will be the alignment which will be left. And the width we're going to want is, let's say, 8. First name is 10 wide. Page down. So now we can say list persons fname. And there's my first name. dict person's F name. Our label didn't take, so we're going to replace the label with, oh, that's what didn't work, first name. And we're going to go to line 5 and delete that. Nope, we're going to go to line 3 and delete that. And then we're going to go to line 4, because you see this is only 9 characters long, and the 8th and 9th lines are on the wrong lines. That won't work. So go here and insert a line and just make a space. And now everything lines up perfectly. And then we say list person's F name. And there's our label, first name. Now we're going to copy dict person's F name to L name. Remember I told you if we just want to copy it to the same file with a different name, we don't have to use the open paren. So now we have the 2 items in the dictionary, and we can say list dict persons F1, F2, F3. That'll be enough for now. So we've got an F name that actually says first name, and an L name that also says first name, and it has the wrong field number. So let's fix that now. Let's add dict persons L name. And line 3, that should say last, not first. So we'll change first to last. Voila. And we're going to change line 2. The field number should be 2, so we'll change 1 to 2 and file it. Then we would say list person's F name, L name. There you go. Okay, so we wrote a program. There it is. You can copy it. You've seen it plenty. You can use it yourself. Practice with this. We wrote a program that accepts keyboard input from the user, then stores that input in a database with a sequentially incremented key number. Let's have a look at that, by the way. CT dict persons, what did I call it? Key list. There it is. It has a 1 in it. So let's create another record, just for good measure. What is your first name? Mickey? Mouse? Really? Oh, very good. Now let's look at that. Now I just hit the up arrow twice. If you've got the proper terminal settings set up, the arrow keys should cycle you back through your command list. So we're going to look at that again. Now it has a 2 in it. And if we list, we've got 2 people listed in our database file. So we've covered all that. I hope that helps. If you have any questions, be sure to contact me at info@thinkware.com. I'm perfectly happy to help you with any training issues you have. And that's all we have for today. Enjoy.